And today's lecture is perhaps the most important lecture in the whole course. It might be the most important lecture because climate change is the most dramatic, unsustainable development we see today. We could use the whole course for just climate change, but of course it's only one opportunity now today. So listen very carefully. Global warming is the main result of climate change. And it's perceived in very many ways: melting glaciers, water shortages, drought, extreme weather, tornadoes, storms, tropical diseases come further north, extreme hot weather, sea level rise, forest damages, etc., etc., etc. I will discuss them in 5 categories, and we start with the heat waves and droughts. So the heat waves mean that you have periods of very hot weather. It leads to excess mortality, that is, people die. For example, in 2003, there was a heat wave in Europe, and we have about 30,000 extra deaths in Europe. Much of it depended on old people didn't drink enough. They were unable to, protect themselves from the hot temperatures. Hot weather also lead to fires because forests are getting drier and drier. Harvests are being destroyed because of this. Water scarcity is increasing and so on. This is an example from Australia, which last year had extreme weather. You see the dark red areas had 45 centigrades or more. It lasted for several weeks, and in some areas there hasn't been any rain for years. So it led to enormous fires all over the country, and many villages and towns were simply left without people because all the houses were on fire. Similar things happen in the west coast of United States, in California, very similar events. And this was so bad that animals in Australia could not take care of themselves any longer. It was too much. So this is one koala that's being saved by people who try to help wildlife. And some insects, for example, they simply disappeared because they were unable to survive in these hot weather events. This is California. And of course, you see again that the hot weather, the lack of rain and so on led to these droughts. The very strange thing is Australia is the most important coal producer in the world. They are exporting coals more than any other country. They should stop using coals because black coal is the worst for climate change. You see here that if we have a small increase in average temperature, it means that the extremes are becoming more extreme simply. So it doesn't mean that the whole temperature changes, it's just the extremes that changes, since there is a distribution of temperatures over such a curve. Second topic, melting ice of the world. See if you can get this. Here. You see this? This little film there? It's from...
No, we can't see it.
You can't see it? Okay.
No.
Let me see if I can get it into... I have a little film here. It's... How do I get it to show now? Of course. Jag har det ju på min skärm, Mattias. Vad gör jag då?
Du kan försöka att dela den skärmen som om du byter i share screen, om du har den öppen i internet eller någonting, så kan du dela den delen av skärmen istället.
Jaha. Ja, den är inte så väldigt viktig. Det är mest... Jag ser ju inte den delen av skärmen som jag kan... Jaha, nej. Ja, vi får kanske ge upp om det där då. Ja, det är svårt det här. Ja, jag tog den vägen nu då. Det här förstår jag inte. Nu är jag inne på... Jag förstår inte vad mitt zoom tog vägen någonstans. Det är bara... Så här. Fan också. Sorry, det här förstår jag inte hur det gick till faktiskt. Ja, där har vi någonting. Okay. Are you able to see my pictures again? Sorry about that.
Yes.
Yes.
I have this thing that I want to get rid of also. Ja, det försvinner inte det där. Jag lägger det där istället. Yeah. Yes, so when it comes to melting ice of the world, you have the glaciers that are melting and big ice mountains are disappearing into the oceans. It's especially the Arctic, Greenland, which we saw in the picture, and the Antarctica. This is one example. It's on the bottom one you see the on the top one you see the this glacier in South America, how it was in 1928. On the bottom you see how it was 2004. So you see it's all melted. You have similar thing in the Himalayas, where Amo Darya gets its water from. This is a very important picture then. It's the North Pole. You see the ice around the North Pole, Arctic ice, has been reduced year by year since decades. It was the minimum summer ice was in 2012. You see on the picture the previous where the ice was previously, the red limit, and now the white one is what it is in 2012. And this year it was the same in 2020, September 2020, it was the same. It is predicted that summer ice around the North Pole will be gone somewhere between 2035 and 2050. This is a quite important development. Here you see it again, what it looks like. And on the lower curve, you see how the ice is becoming bigger during the winter, of course, and slower during the summer, and smaller during the summer, when the sun is shining all the time. Jag förstår inte varför det är där. Here you see again how the summer ice is in the 2012 curve, and the steers curve is very similar. It's being monitored, day by day by the American authority for looking at these things. Jaha, nu kan jag inte mata fram det där längre. Varför inte det? So, and this is from Antarctic ice sheet. It turns out that it's melting quicker than people predicted, and it seems to depend on the fact that the layer between the ice and the ground in Antarctica, because Antarctica, it's ice on the continent, it's a solid rock under the ice. It's melting there, so it's gliding on this water that is between the glacier and the rock. That's why it's getting much, much quicker than predicted. It's similar thing is happening in Greenland, but of course, when it comes to the North Pole, it is just the ice on the sea. There is no continent there. Okay, we'll go to the third part, increased cyclones and floods. So we have flooding of coastal areas, destructive storms and tornadoes. And this is dependent very much that the storms that form in the oceans getting more, has more energy because of the warmer water. So these tornadoes are getting really very bad. And this is just one example from Indonesia, which has in the fall of 2020 had terrible storms. Similar things happen in Florida and in Eastern Africa, Mozambique. This in Mozambique, it destroyed large part of the harvest this fall. So it's very destructive for the people living there. Oceans of the world are changing. It means that the sea level is increasing, is rising. It depends on several things. Most important is that the water gets warmer, so it's expanding. So this is one thing. And the second thing important is that ice are melting and contributing to the volume. But the sea level temperature increase means that coral reefs are destroyed. They can't take this increased temperature. They are developed for lower temperature. And also there is a decreased salinity because of the input of fresh water. It's also bad for the coral reefs. There is also a acidification, which depends on the fact that the carbon dioxide produced are dissolved in the ocean water to a very large extent. So it is the pH of the oceans are decreasing. It also means that the capacity of the oceans to receive more carbon dioxide is decreasing. So the marine ecosystems are in bad shape here. This is a curve of the sea level rise. You see, it's the prediction of this is difficult. They don't know quite, these meteorologists, how it should be understood. But it might, in the worst case, in year 2100, be 1 meter above the present level, or it might also be a little less. But then it will increase, it will continue to increase. So then the 1 meter level will come later, but it will come. So we predict that many cities on the coasts around the world will be flooded. This is just a list of what it will look like. Miami, Rio de Janeiro, Osaka in Japan, Shanghai in China, and so on will be flooded. In fact, very much of the world population live along coasts. Island nations in Southeast Asia will be simply submerged and disappear even. Some islands will simply disappear. And this is about the coral reefs. It's from Australia, the Great Barrier Reef on the southeastern part of Australia. You see on the top what it looks like when it's fully alive, and on the bottom how it looks like today. It's whitening. The corals are whitening, and this is very important because many fish species use these coral reefs as a sort of, part to reproduce. This is children's corner of the fish of the oceans. Terrestrial ecosystems of the world are changing also. So species are moving further north because of the increasing temperatures. It's about 5 kilometers a year, so it's really dramatic differences. And ecosystems depending on migration are unbalanced. I don't know how to get rid of this thing here. I can't get rid of it. Well, anyhow, so you see this polar bear is sort of symbol for these species that are living further north, and of course they are threatened because of the increased temperature. In fact, temperature increase is very different in different parts of the world, and in the Arctic world it is the highest. It's about 6 degrees today. It has increased about 6 degrees. So another part of this is that the tundra along the Arctic oceans, in Siberia, in Alaska, and so on, is melting. The permafrost is melting. And it also means that the permafrost is giving away methane. Methane is a very strong climate gas. So this is a bad situation. It also means that the tree line on all mountain areas in the world are moving up. So species living on higher altitudes are getting less and less areas to live in. Well, this was just a few words about the consequences of global warming, which is very alarming. Perhaps the most alarming is that the Arctic areas, the areas high north, are changing extremely rapidly, much more rapidly than one thought some years back. The causes of global warming we need to look at now. So you see, this is a very simple summary. On the lower graph, you see fossil carbon emissions. And you see it started to increase because of the use of fossil fuels. So in the end of the 20th century and beginning of this century, it's increasing very much. So the consequences of this is, of course, that burning carbon makes carbon dioxide and is accumulating in the atmosphere. So you see the atmosphere carbon dioxide is the second graph from below. And when we have more of carbon dioxide, which is a greenhouse gas, we have a higher temperature. This is a top graph. So they all follow. It's very simple chemistry. Here you see the greenhouse effect. It means that carbon dioxide in the atmosphere, it is like a blanket of the world. So the solar radiation goes through this this layer of carbon dioxide in the atmosphere coming to the surface of the Earth, which is getting warmer. So heat radiation is going back up. It's absorbed by the carbon dioxide, and about half of it is returning to the Earth, and half of it is going back up. So it's functioning like a blanket. So these gases that have this property, they are called greenhouse gases. And carbon dioxide is the most important, but methane is much more efficient than carbon dioxide. It is about 20 times more efficient when it comes to absorb heat radiation. But it has a very much shorter half-life. So after about 10 years, half of it has been oxidized to carbon dioxide and so on. But carbon dioxide has a very, very long half-life, many hundred years. So it will stay there for a very long time. The atmospheric concentration of carbon dioxide in parts per million has been measured in Hawaii by Scripps Institute of Oceanography since the mid-1950s. So you see this is how it looks like. If you remember the planetary boundaries for carbon dioxide in the atmosphere is 350. So since 20 years back, it has been passed. So now we have 415 or so. It's much, much higher. You see also that this curve is wiggling up and down all the time. It depends on the fact that it is lower during our summers because of growing vegetation on the northern hemisphere, and during our winters it's summer on the southern hemisphere, but it's much less terrestrial ecosystems there, so it doesn't absorb as much carbon dioxide. So it's going up and down in this way each year. So now we have record high carbon dioxide concentration in the atmosphere. And from that follows that we have higher temperatures. And of course, that depends on several factors, not only carbon dioxide, ocean currents, weather systems, and so on. So it's varying a little up and down. But you see the red line is 5-year average, and it's fairly much getting up. Today, the temperature increase compared to pre-industrial levels, the pre-industrial when they didn't use fossils, it's about 1.2 degrees, even 1.25 in fact. 2020 was the hottest year measured up to now, the same as 2016. It was the former hot record. Now I would like to show this film. Let's see if it's possible. Oh, perhaps it's a very dramatic way of showing how the temperature is increasing, but we'll see if we can do it later. It's what didn't work so well with the last effort of me to show a film. So let's look at this instead. This is what is called relative forcing. That is what is actually contributing to the increased temperature. So you see all these things. So you see, this is carbon dioxide emissions, is this one. Methane is this one. Halocarbons is another greenhouse gas. And dinitrogen oxide is another one, also contributing a little. Aerosols is reducing this. And of course, also I should say that increased solar radiation here doesn't change anything at all. So by far the most important part of this is carbon dioxide concentration in the atmosphere, perhaps together with methane concentration in the atmosphere. For some reason it's difficult now again. Ja, nu kan jag inte få fram det här längre. Ja, nu kom det. Okay, this is now global temperature and carbon dioxide concentration on the planet over the last 400,000 years. And this is something that has been measured in ice cores from Antarctica. The Vostok ice core was taken by Russian scientists and is being measured very carefully. You use oxygen isotopes and carbon isotopes to measure that. So you see here you have periods between ice ages. So these are ice ages. This is melting after the last ice age. This is the previous ice age, and so on. That's carbon dioxide concentration, and it follows very carefully the temperature. So higher carbon dioxide concentration, higher temperatures, and so on. Now you see this is the increase in carbon dioxide concentration that we have seen up to 2004 here. To 375, that is passing 350, so we thought was what we can manage with. But now it continues, you know. So if nothing is being done when it comes to fossil fuel use and so on, it will be up to 700 ppm 2100. This is something we have to avoid. In fact, if you look at this curve, so you can see over even longer period, this is some measurements in the ice cores and other measurements, and then modeling done by the Climate Institute in Berlin. It's covering 3 million years. And we see during these 3 million years, the temperature variability was not more than 2 degrees, you see here, or above pre-industrial level, never more than 2 degrees. That. And then during the ice ages, we have been down to -4. So the whole temperature span is about 6 or 5 degrees. This little period here is what our life today. So we can see that climate variability is increasing. For example, some years it was very warm in Russia. It was a lot of wildfires around Moscow, so you could even in Moscow you could feel the smell of burning fires or burning forests. Next year, 2 years later, it was North America who had that. It's interesting to note that during the last ice age, the increase in temperature after the ice age was about 0.1 degrees per century. So it took 1,000 years to increase from 1 degree. Now it's 0.16 degrees per decade. So it's much, much quicker, much, much faster. Before, we had CO2 level started to increase because of an increased temperature. Now it's the opposite. We have increased temperature, we have CO2 is level, CO2 levels are increasing, and that's when it's followed by increased temperature. Yeah, so this is some basic facts about that. All these things that are happening are related to each other. We have feedbacks and tipping points. For example, the Arctic sea ice is melting. It means that the ice, which is reflecting the sunlight, is decreasing. The reflection is called albedo. So you have less albedo when you have less ice. On the opposite, the ocean, the water surface is dark. So that is absorbing sunlight. It's increasing the temperature. So this is one feedback, you see. We have the Arctic permafrost, it's melting. And when the permafrost is melting, methane is emitted. And of course, methane is a strong gas, greenhouse gas, so it is contributing to more melting of the permafrost. It's another such feedback. The Amazon rainforest is cut down. This means that the evapotranspiration from the forest is being reduced, and the former forest becomes savanna. Today, about 17% of the forest have been cut down in the Amazon. You know, if this increases over a certain level, it will be self-enforcing. So we have estimates are when it has passed 25% cutting down on the forest, then we will have such the whole Amazon will become a savanna. Another one, fourth, such Atlantic circulation is decreasing. Atlantic, the big, currents in the Atlantic Ocean is depending on the salty water becoming more heavy when it comes up to the north. This is now decreasing because of the melting Greenland ice in particular. So the circulation is decreasing. It's decreasing with about 15% today. You see here a curve of about 13 such tipping points. All over the world they appear, and they are connected in various ways. You see here. And in fact, it looks like the melting of the North Pole ice is a very important part here, because it contributes to the melting of Greenland ice. It contributes to the melting of the permafrost. It is influencing the ocean currents. So it looks like it's raising the alarm of this, what's going on right now. We have to stop global warming to stop this process simply. Okay, thank you very much. I hope you have understood some of this. There is now a 30 minutes break starting, and during this break, you are encouraged to discuss between yourself, how do you notice climate change in where you live, and can you think about how you can reduce climate change where you live? And we'll see each other after 20 minutes now. Everything is about 20 minutes delayed because of the because of the trouble in the beginning. But anyhow, we'll keep that 20 minutes from now. We'll see you again. Thank you very much. Okay, we have to continue here then. So this second part of the lecture will deal with the what we try to do to combat climate change. So the basics of climate change. So it is, as we said, when we use coal, oil, and gas, we form carbon dioxide, which is emitted to the atmosphere. There it functions as greenhouse gas, GHG, and contributes to what's called enhanced greenhouse effect and global warming. The climate system of the planet is complicated, and it's studied since the 1980s by the IPCC, Intergovernmental Panel on Climate Change. It publishes reports regularly, and the next report, the 6th report, will be presented this year, 2021. With the existing concentration of greenhouse gases in the atmosphere, we will have an increased global mean temperature of about 2 degrees in the middle of the 21st century. If it continues like this, we will have much more, perhaps 4 degrees at the end of the century. So it's serious. So we're dealing here with two issues. One is to adapt to the situation we have, is called adaptation. And the other is to counteract it, it's called mitigation. The economics of this adaptation and mitigation was studied in the Stern report. Stern, it's an economist, World Bank economist. He made a very, very detailed report, several hundred pages, showed clearly that it's better economy to mitigate than to adapt. It's much less expensive. You know, the impacts of climate change on our world today cost billions and billions of dollars. We need to know something about global carbon flows. So the carbon flows between the atmosphere, the above ground biosphere, and the ground of the sea. All these flows have increased considerably since coal, oil, and gas are stored as fossil carbon in the ground. Now we use them as a source of energy. We talk about carbon sinks and carbon sources. So the fossil is a carbon source, and carbon sink is, for example, a forest that is growing. Overused soil is a carbon source. So sinks and sources you need to keep track of. When carbon is stored in the sink, it's called sequestration, and when it's released from the source, it's called emission. This is the carbon flow. You see how much there is in the atmosphere, how it's taken up by the the plants and the biota in the ocean. It's finally sedimented. It's bound to the bottom. For example, as calcium carbonate, and it's slowly transported up to the surface again and goes to the atmosphere. So this is very, very slow cycle of carbon, which we have speeded up thousands of times. So what does the carbon we have fed into the atmosphere come from? You see here fossils is 2/3 almost, 62%. We have energy. It's about at methane, 6%, agriculture, 7% methane, and other sources of carbon dioxide, which is not fossil fuel. It's in particular from the agriculture. It's 14%. And then we have a little dinitrogen oxide from agriculture also. So this is an old picture, but I'm afraid it's still valid. I mentioned the Intergovernmental Panel on Climate Change. It was formed in the 1980s when the climate issue was discussed very much, and some meteorologists decided that we need to have a standard answer to all these questions based on sound research. So IPCC is coordinating and reporting of the research of thousands of scientists. And it's reported in these assessment reports every 5 years. And as mentioned, the next report will come this year. Well, adaptation, how is this going on? Well, to adapt to the changes we have, you should not build in coastal areas. You have to rather build flood defenses because there will be floods. You have to protect especially cities from extreme heat waves. Cities are warmer than the surrounding countryside. You have to develop crops which grow in higher temperatures, more heat-resistant crops. And you have also switched to drought-resistant crops, and so on and so on. You have to learn to live with a higher temperature. For example, this is from Chicago. You see the roof of the building. Either it should be white, because white roof reflects sun better, so it decreases the heat urban effect a little. Or it could be green, that is, you grow things on the roof. And it has the advantage that when it's the excessive rain, it absorbs the water in a much better way. So you don't get so much flooding. So these green roofs we have in many cities, and it's quite a good way to develop resistance against climate change. Here is another thing that is coming from the Netherlands, Rotterdam. It's the biggest port city in the Netherlands. And of course, they are living below sea level already. So they know much about how to defend themselves from increased sea level. So this is, these are various ways to defend themselves built in the port of Rotterdam. But it has now to be built on very many places. For example, Venice is such a city that is almost also under sea level already. Venice, it's a city in Italy that is filled with culture from ancient Italy. Well, mitigation is that how to stop the climate change. And of course, we have to stop using fossil fuels. We have to stop using fossil fuels for heating, driving cars, and so on. Instead, we should take train. We should not fly. Fly is using much fossil fuels per kilometer. We should change to renewable energy. We need to develop forestry. We have to build in wood, not concrete. Concrete is a big emitter of carbon dioxide. And so on and so on and so on. There are very many things to do. We need to know about budgets, carbon dioxide budgets. How much more carbon dioxide can we emit to the atmosphere without risking that the world temperature will pass 1.5 degrees or 2 degrees? This is presently about 500 gigatons of carbon dioxide that we can emit still to the atmosphere. if we pass this amount of carbon dioxide, temperature will be higher. This budget can be divided between countries. It can be divided within countries, between cities, and it even can be taken down to the individual if you wish. The budget for Sweden is about 300 million tons. But we are emitting today close to 50 million tons per year. So we need to be carbon free in 8 years. And I'm afraid that will not simply happen. But that is the big task we have in front of us. You can see this curve is from 2017. You see how many gigatons of carbon dioxide you can emit if we want to stay within 1.5 degrees. It is simply the surface area under this part. You see, if we start in 2016 to reduce carbon dioxide emissions, we'll come along this curve, the green curve. If we start in 2020, now we have the blue curve. And if we start in 2025, we have the red curve. And of course, this corresponds to a certain percentage decrease every year. At present, it is 7% about. We have to reduce 7% per year. And in fact, 2020, it was 7% less emissions. This was due to the pandemic. So people traveled much less. Very many activities, restaurants, etc., stopped working. People work from home and so on. So it was 7% less carbon dioxide emissions. We need to continue with that year after year. It will be really a big job to do that. If we say we should go to 2 degrees instead of 1.5, then we have the budget is of course bigger. It's about 800 gigaton, and we have this line to follow, the blue line, and then we have more time. So this is the challenge in front of us. You can see here carbon dioxide emissions per year in developed and developing countries. So this is the industrialized or developed countries. It has in fact gone down a little, but it is increasing in developing countries still. So this is where we are up to 2019. As I mentioned, 2020, it has been reduced quite much. This is where it comes from. We have seen it before many times. Energy, fossil fuels are used to produce electricity. Agriculture, transport, use of fossil fuels in producing carbon dioxide emissions. Agriculture, fossil fuel, carbon dioxide emissions. Industry, carbon dioxide emissions here, etc. This is a household or residential level. This is from which countries the carbon dioxide comes. And you can see here that North America, United States is a big emitter, really big emitter. Of course, also Middle East is a big emitter. Europe, so and so. Sweden is best in the Nordic countries. When it comes to this part of the world, of course, you see it's somewhere in the middle. The poor countries don't emit much carbon dioxide. Australia is a really bad case. Sorry about that, Australia. You can also see how much carbon dioxide the countries have emitted since industrialization began. That is what they did to destroy the world to the extent that we have today. And then you see United States is a really bad case. They have, produced much carbon dioxide emission during their existence. The same with China, bad case. England, England started with using coal and produced the steam engine. And of course, Russia, or at the time Soviet Union, is also a bad case. So they should reduce more than anyone else, exactly. But of course, they don't do it. Now we need to talk about the United Nations Framework Convention on Climate Change, Unfccc. This international convention was negotiated finally at the UN conference in Rio de Janeiro in 1992. 1 year later, or 2 years later, it went into force. Today, 194 states are parties to the convention. That is, in practice, all states on the earth take part in this convention. And the objective of this convention is to stabilize greenhouse gas concentrations at the level that would prevent dangerous anthropogenic interference with the climate system. So you see, this is a rather general expression of what people have signed, what they are obliged to do because of being part of the convention. The convention parties meet every year in so-called conferences of the parties, COPs. These conferences, they can agree on something that's more detailed than the convention itself. And such detailed plans are called protocols. In 1997 in Kyoto, Japan, a protocol was signed, the Kyoto Protocol. And in this protocol, some countries, 37 states, and the European Community decided to reduce greenhouse gas emissions by 5% compared to the 1990 level for the period 2008 to 2012. This protocol entered into force 2005 after Russia had signed. So you have some countries who joined the protocol and some which actually left the protocol. For example, Canada left in 2012. Canada is a really bad case here because of their production of tar sand, which is a big emitter of carbon dioxide. Australia both came into the protocol and left the protocol, depending on if they have a right side government, they leave the protocol. If they have a left government, they join the protocol. Well, so this is continuing. There are more periods after 2012. In 2009, that is more than 10 years after the Kyoto meeting, there was a COP15 in Copenhagen, where they intended to agree on another protocol. And you see here Barack Obama in the middle. You see Angela Merkel to the left from Germany. You see Sarkozy from France, etc. They were not able to agree on anything. The countries of the convention did not agree on being, requested from above, so to speak, to have certain obligations. So what happened after 2009 is that other approaches were tried. And of course, when it comes to Europe, European Union, this European trading system was put into effect, and it's actually after the Kyoto obligations that it went. It is a so-called cap and trade system. That is, within the cap and trade system, there could only be so and so much amounts of carbon dioxide emitted. And in the system, there is presently 11,000 industries in Europe which take part. And all of these have certain amounts of carbon dioxide they have the right to emit when the period starts. And it costs something for them to do that. So if they want to emit more than the right they have from the beginning of the period, they have to pay for it. And if they emit less, they can sell their rights of emission to others and earn money on that. So this has been quite effective right now. In fact, it's becoming more effective right now. The third trading period we just left is 2013 to 20. What happened there is flight traffic was included, some more greenhouse gases were included, and so on. Since 2021, 1st of January, just last month, it's the fourth trading period started. And now the conditions are more serious, which means they have less rights to emit. So the price is now, I looked yesterday at the price, it's 38 euros per ton. And this in this fourth trading period, it's going to be reduced. That is, the amounts emitted going to be reduced by 2.1% each year up to 2030. So this has been quite efficient, the European trading system. You know, in spite of the Unfccc, it has been not much happening. So there are many protests around the world. This picture is from a climate march in New York some years back. It was 500,000 people were marching along the streets of New York, protesting that countries didn't do anything. In fact, they did not do much at all. So, and of course, this was leading to the COP, the COP21 in Paris in 2015. And here actually there was an agreement reached. And the agreement was still not very much in detail, but we did have an agreement that every part of the convention should make contributions to keep the temperature increase below 2 degrees and if possible 1.5 degrees. So this is very important, the Paris Agreement. You see people here are extremely happy that they were able to get everyone on board here. 192 countries signed. And the trick here was to do it from below rather than from above. Each country were asked to tell us what they were willing to do in terms of contributions to this degrees of fossil fuel reductions. It's called Intended National Determined Contributions, INDCs. So 150 countries told exactly what they were prepared to do. And that was dealing with 87% of the global emissions. So it was very important. And if all these countries actually do what they say, then we will end up with about 3.6 degrees temperature increase. So it's not at all enough, not at all. But what is important to say here that we will have a very important meeting this year. So what does the Paris Agreement mean? Well, the national determined contributions, if they are all being done, it will give 3.6 degrees temperature increase, is according to the present models. States signed the agreement assuming that they will be saved by technology developments. For example, carbon capture and storage, or negative emissions, the bioenergy carbon capture and storage. So they really did not think about reducing their fossil fuel use as much as would be required. Or they were, assuming that they could plant forest enough to take care of it. So it's not as good as we could assume. So now we come to the next very important step here. So we have these COPs annually for now almost 30 years, since 92. The COP21 in Paris was of key importance because there was an agreement signed by all these countries with the national contributions decided. Now, this year in 2021, the COP26 will be in Glasgow in United Kingdom. And now countries are asked to update their commitments after the Paris Agreement. They should have stronger commitments than in Paris to end up below 2 degrees. And we don't know what it will be, but it has been a lot of talking about this. How far can you go? So this is this situation we have today. We hope there will be a much improvement in Glasgow in November this year. What has happened, which was quite encouraging during this year, just the last month, in fact, United States, after Donald Trump was out of the White House, have entered the Paris Agreement again and promised to be net zero emissions by 2050. No carbon dioxide emissions by 2050. European Union has since before promised to be carbon neutral by 2050. China, as a response to United States, emitted their policy to be carbon neutral by 2060. So they are on the train, so to speak, but not so strongly as others. If we look at Sweden, the policy is to have net zero emissions by 2045. So it's a little bit better, and it's a little smaller country, and it's a little easier to agree on things. Uppsala, now we're coming to a city, not a country. Uppsala has the policy of being net zero emissions by 2030. So, and it's not only Uppsala, there are many cities have said that they will be net zero emissions by 2030. And I should say, some municipalities have already net zero emissions. I mentioned that, for example, the islands and so on before. So this is the situation. It's a little encouraging, you can say. Some people actually try to do something to improve the situation. So let's hope for that, but be aware that everyone has to contribute. What is important to notice that the protest against this inactivity to do serious steps to reduce climate change is coming from the kids, the children, the school children. And it's called Fridays for Future. And there are millions of school children around the world who have joined this movement, Fridays for Future. And this is just one. It's from Aachen in Germany. There are 50,000 school children in this city who just are marching. So I'm proud to say that this whole movement was started by Greta Thunberg, is a school child in Stockholm. She was just 15 years of age. She, in connection with the parliamentary election in 2018, she said that the most important thing that the parliamentarians should, promise their voters is to improve climate situation. So this is her action, was to sit every day in front of the Swedish parliament with this sign saying "Skolstrejk för klimatet." It means school strike for climate. That's how it all started. And then some people came and sit with her, and then it started to be in more countries and so on, and it spread, So now it's, as I mentioned, hundreds of thousands of school children all around the world. I don't know how it is in Uzbekistan or Karakalpakstan. You have to find out. Fridays for Future. Yes, this is promising. So what can you do yourself as an individual? As an individual, you can look at transport. We talked a little about that. You can talk about what you eat, the food. You can see how you deal with your home. This is rather clear. These are 3 areas where you can influence personally. The least you can do is as much as possible. The least you can do is as much as possible. This is a message from me and friends working with climate issues. And you have since before the reading course. I put together a basic small book of 100 pages, and I suggest you read the first part of it. Thank you very much for today. Thank you.